Good morning, everybody. We will start our first lesson from Algebra 2 book. This is lesson 5, systems with 3 variables. The objective of this lesson to solve systems in 3 variables using elimination and substitution. And because this lesson takes too long time to solve one question, we will not solve all questions. We will solve question on substitution and in elimination, and I'll put you the answers of the got it and the homework questions. And if you have any further hesitation about the lesson, you can ask me at any time. To warm up for this lesson, we have to recall our understanding for solving equations. If I say x plus 3 equals 5, and I told you I want the answer of this equation or solve this equation, you will tell me that I'll move the 3 to the other side. It will be with a negative sign, so x will be 2. By this step, I finished solving the equation. What if I have a system of equations? The system of equations means I have more than one equation. We took in grade 8 and 7 the system with 2 variables. Means I have x and y equals 7, and I have, for example, negative x plus 3y equals 5. And he told me this is equation number 1 and this is equation number 2. And he told me to solve the system of equations. When I say solve system of equation, this means find an ordered pair for x and y that satisfy both equations. For example, if I have 2 equations and I drew, for example, any equation, the first one, and I got it by this line, and the second one this line, the solving of this system is the ordered pair where the 2 points intersect. So this is the meaning in graphing. I just graph it for you to understand what we're doing. Now, for this system that we have it in here, we have 2 ways to solve. We have elimination and we have the substitution. When I have the elimination in English, the elimination means to eliminate. Means I need to cancel one of the variables from my both equations, and then I will have an equation with one variable. I'll find this variable, then I'll go back to any of the equation to find the answer. Means if I have those 2 equations, I'll add both of them. So if I say x plus y equals 7 and negative x plus 3y equals 5, if I add the both equation, this will give me 0. 3y plus y, it will give me 4y. This means y equals 2, 3. And by going back to any of the equations, I will say that, let's erase this first. I will go back to substitute in my equation. Okay, and I will say if x plus y equals 7 and the y equals 3, so x will be 4. In this way, I applied the elimination, but in the system with 2 variables. Let's move ahead to see problem number 1. The mechanism of solving is the same, but we will have another variable which is z. Before we solve this one in here, question of getting ready is telling you that we have those 3 balances. He gave you that in the first balance that 2a equals b. This is the first equation from the first balance. The second one, c equals 3a. Because they are balanced, they are on the same level. That's why we knew that each side is equal to the second side. And the third one is what? C plus B equals 10 pounds. Now what I wrote in here is called a system with 3 variables because I have A and B and C. Solving this variable, solving this system, I have to find the value of each of them, A and B and C. A and B and C. Now, the meaning in graphing, as I showed you in the first slide, that when I graph, I should have a point that the two lines intersect in. For the systems, I'm talking about a third dimension. This means we are not in the XY coordinate plane. I am in the space for the third variable. If you look at those 3 figures, we say that my system doesn't have any solution if any of the planes didn't intersect with the other 2 planes at the same point. So if you can see from the figure in here the 3 planes are intersected in a point, so I say one solution. Here they intersected in all of this, all along this line. This means infinite number of solution. And here the 3 of them are parallel, so no intersection at all. And here 2 are intersected with the third separately. This means no exact intersection between the 3 of them. And the third one, each 2 are intersected together, but not the 3 of them. So in this case, we will have no solution. Here, infinite number of solution, and here one solution, which is our normal answer for most of the question. If I will start talking about solving system with 3 variables using elimination, and I said earlier, the elimination means I need to take one variable, which is the easiest to be eliminated from my set of equations, and remove it, and I change my system into 2 variables system, and then I will find the variable's value. Then I'll go back to any of the equations to find the third variable value. Let's start. Here we numbered these equations to make it easy for you to track the solving. And in solving such a question, you have to be very organized to not be lost or mix with the numbers. The first equation is 2x minus y plus z equals 4. X plus 3, y minus z equals 11. And the third one is 4x plus y minus z equals 14. Now I need to look at the 3 equations. Which is the variable that easier to be eliminated? How can I tell? The coefficient of z, which is the number multiplied by the z, is all the same in the 3 equations. Yes, in the first equation it is plus 1, in the second equation minus 1, and the third equation is minus 1. However, this by adding and subtracting equations will be not a problem. But for example, x, it's in the beginning 2, then 1, then 4, so it will be in a need for more work. Let's start. We will eliminate z. So I'll take equation number 1 and 2 and add them. Equation 1 and 2 and add them. When I add 2x plus x, it will give me 3x. When I add negative y plus the 3y, it will give me 2y. Z plus z and minus z, they will go together, and 4 and 11, it will be 15. Now I got the first equation, which I numbered 4 in 2 variables. I'll take equation number 2 and 3, and I will add them in the same way. I will, if I add them, I will keep the z in here. Let's try adding them. X plus 4x, it will be 5x. 3y plus y, it will be 4y. minus z plus minus z, it will be minus 2z. So did I do anything? No. So I'll decide that I will subtract them. So I will say x. So adding or subtracting is not a problem for me. However, you need to make sure that the variable that you want to eliminate will vanish, will not be here anymore. So x minus 4x, it will be negative 3x. 3y minus y, it will be 2y. And minus z minus z, it will be plus z. So this will be 0. And this is 11 plus 14, negative 3. And minus 3 minus 14, it will be negative 3. Now, in this case, I have two equations. This is the equation and this is the second equation, which both of them has two variables only. Step number 2 in solving, I'll take those two equations, which are 4 and 5, and I solve them as normal solving. I'll add them. And we said adding or subtracting depending on the sign that you have. If you have both of them the same sign, you will subtract. Both of them negative, subtract. Both of them positive, subtract. If one of them positive and negative, the second one, you need to add. So here we will add both of them. So 3x minus 3x, it will give me 0. 2y plus 2y, it will give me 4y. 15 plus negative 3, it will give me 12. So 4y divided by 4 and 12 divided by 4, the answer of the first variable is a 3. I will take one of those equations, which is easier for me to substitute in. Here we chose equation number 4. We said if y equals 3, what is the value of x? And by substituting in y in here, instead of 2y, so we substituted 6. 2 times 3, 6. And we got the answer of 3. Now I have two values. I have the y value and the x value. What do you think I will do to get the third one? I'll go to any of the equations from above, which we chose equation number 1, and I will substitute 4x 3 and 4y 3, and I will get z, which is my third variable. Then I will write at the end my answer as an ordered triple. The solution is in order, so I start by x, then y, then z, and here will be your answer. So the first way is I decided which variable I will eliminate. I will create two equations from two variables, and then I find the values of the two variables as I'm solving two steps equation or system of two variables, and then I substitute in any of the equation. You choose the easiest for you. The fourth step to write it as an ordered pair. Now problem number 2, it's the same on elimination. However, the coefficients of the x and y and z are a little bit different. So if you look at x to decide which variable I will eliminate, none of them has the same coefficient. So I have to deal with one of the variables in multiplying or dividing to make it the same. Here we choose to eliminate y. Why is that? Because in the first and the second equation, the y coefficient is the same. So I can easily subtract the two equations, 1 and 2. I can subtract them and I can get x plus 4 plus z equals 4. Question number, and then I will deal with the second and the third equation. The second and the third equation here, and I will think, how can I eliminate the y? The y here has a coefficient of 1 and here negative 2z. So I will multiply the first equation with 2. So I will have, instead of 2x, 4x, instead of y, 2y, and instead of 3z, I will have 6z, and the answer as well equals 14. Don't forget to multiply every single step in the or term in the equation to keep the equation the same, because if you multiplied one term and forgot about the second, this means you change your equation. And the second equation stayed the same. Then I added the two equations and I end up with equation number 4 and equation number 5. Once I've done this step, my life will be easier. Why? Because I'll deal with 4 and 5 as a system of two variables, and I will add or subtract to give the value of z or x according to my question. Let's see here. I have x plus z equals 4. The second one is 3x plus 7z plus 24. I can multiply up by 3 or negative 3. It doesn't matter. Because if I multiply it by 3, I will subtract the two equations to get the value of the x is 0. Here, we multiplied by negative 3 to make the coefficient the same number. Negative 3x minus 3z equals negative 12. What did we do with the second equation, which is number 5? Nothing. Then we added the two equations here and we eliminated the x. We got only 4z equals 12 and z equals 3. Then the last step, we substituted the z value, which is 3, in one of those equations, which is number 4, okay? And we found the value of x to be 1. After finding the x and the z, this is the most important part in the question, and we can easily take any of the equations 1, 2 or 3 to find the value of z, according to which is the easiest one for you to substitute. Now, we substituted in one of the equation, which is x plus y plus 2z, and we found that y equals negative 4. The solution is written in order triple, which is the way that we have. To make it more close to your mind, what's the meaning of intersection in 3 planes? This figure shows you that using a graphing calculator, they drew the 3 equations, which is 1 and 2 and 3, and they found that this is the point, which is 1, negative 4, 3, which is our solution, is the intersection point between the 3 of them. Now, I put you the got it questions answers, so you try after understanding the problem, applying it and checking your answer. We will go to the second step, which is the substitution. I advise you to watch the video in 2 stages. Finish the elimination, solve the got it question, make sure that you have the steps correctly, then you will do the substitution. At the end of this lesson, which way is more convenient according to the question? Some questions are easier to be solved by substitution. Some of them are easier to be solved by elimination. However, nothing can make it only in substitution or in elimination. If you are more comfortable with one method, go for it, okay? Unless the question asks you to solve the system using a specific method. Now we will talk about using by substitution. Substitution means I look at my equations here. My 3 equations are 2x plus 3y minus 2z equals negative 1, x plus 5y equals 9, 4z minus 5x equals 4. I look at one of my equation, I find equation number 2. This equation, it's easy for me to move the y in the other side to find that the value of x equals 9 minus 5y. This is the value of x, which is shown in the second equation. Okay, what I will do with it? I will go in the 2 equations equation number 1 and equation number 3 and substitute wherever I find x by 9 minus 5y. If I have something multiplied with the x as in equation number 2, I will multiply the coefficient of x with the whole bracket, which is 9 minus 5y. How? The equation is telling me 2x plus 3y minus 2z equals negative 1. Instead of x, we agreed that we will substitute the 9 minus 5y, but I have the coefficient, so I will multiply 2 times x, 18, minus 2 times 5y, it will be 10y, and then I'll continue writing my equation plus 3y minus 2z equals negative 1. I will combine the like terms, negative 10y plus 3y, it will give me negative 7y. I don't have another term, this is the 18 in here still, and the z, I have it the same, equals negative 1. I will move the 18 to the other side, so it will be negative 18, and it will be added with the negative 1 to be negative 19. And this is my fourth equation. I was able to do the equation with 2 variables. I'll do the same in equation 3. 4z minus 5x equals 4. I will go to the value of x. I will multiply it with its coefficient. I will say 5 times, I open a bracket, I put the value of the x which I found up here, and I will distribute the 5 to the first to the 9 and the 5 to the 5y, and I got the equation, which is equation number 5, in 2 variables. Then I will solve the system in here. 4 and 5, I will see what I will do. Negative 7y minus 2z equals negative 19. I will multiply by 2 because it's very difficult to change the 7 to be 25. So I'll look at the z. Here it's 2 and here is 4. I'll multiply my equation up by 2. So it will be negative 14 minus 4z equals negative 38. And the second equation stay as this. Then I add the 2 equations. I'll get y equals to 1. And the last step, I'll go back to my original system to substitute to find the value of the third variable, which is I can get x equals 4 and y equals 1 and z equals to 6. The order is very important, ladies. This is x and then y and z. So my answer, if I go to my answer in the previous slide, the answer will be B, because he asked me about the value of x in the system. Okay, now we're done both techniques in here, the both ways to solve any system with 3 variables. The difference between them, that in the elimination I decide from the beginning which is the variable that I need to exclude from my system, and I solve it as system with 2 variables. Then I go back and substitute. In substitution, no, I take one of the variables which has usually the coefficient of 1, and I solve its equation for it. Means I keep it in one side, and then I substitute its value in the other 2 equations in the system, and I can get the answers. Okay, now this is the got to 3 answer. Please try it by yourself and tell me if you have any question. The last step in this lesson is when you need to write the equation. You need to write the equations, then you will solve them. We will solve the part of writing the equation to not take too long an explanation in here, and then after writing the system you will choose to write it in substitution or elimination. The question is telling you manage a clothing store and a budget equals $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many as rugby shirts as polo shirts, how many of each type of shirt should you buy? Now, first step, in the first in the first here equation, he told me you manage a clothing store and a budget equals 6,000. When I speak about the budget, this means I'm speaking about the cost. So the first type of equation that he's giving me, that the whole cost of everything I'm managing equals 6,000. I'll leave it aside. To restock 200 shirts, this is the number of the shirts in different types. You can buy t-shirts for $12 each. We're back to the cost again. $12 each. Polo shirts for $24 each. A rugby shirts for $36 each. So he gave me the price of the t-shirts, $12 each, the polo shirts, $24 each, and the rugby shirts for $36 each. Now, if you want to have twice as many as rugby shirts as polo shirts, he said that for every polo shirt, for every rugby shirt, we will have 2 polo shirts. So let's think about it. Let's assume that the t-shirt are X. The t-shirt here are X. The polo shirt are Y. The rugby shirts are Z. Now, the number of the three of them, X plus Y plus Z, equals 200. So we're able to find the first equation. Second, he told me the relation between the rugby shirt and the polo shirt. He said, twice as many rugby shirts as polo shirts. So twice the polo will give me the rugby shirts. Okay, so 2y will give me z. This is the second equation. The third one will talk about the cost. The final cost for everything is 6,000. What's the price of each? The t-shirt is 12, so 12 times the x plus 24 times the y plus 36 times the z equals 6,000. Now, if I got a system like this, which is the easier way to solve it? In this system, I can, as we said, as easy as this to eliminate or substitution. But such a question that I have already z equals to y. So I can use equation 1 and 3 to substitute instead of the z, what? 2y in both equation. In this step only, I can get a system of 2 variables and I can solve it easy. Now, here in the book, they said we want to multiply, since 12 is a common factor for all of the terms in the equation, write a simpler equivalent equation. He wanted to divide the first equation, which is equation number 3, to get the fourth equation divided by 2. He divided by 12, by 12, by 12 because the coefficient of the equation were big for the cost. So he changed the equation to be x plus 2y plus the 3z equals 500. Then he substituted, as I said, for each z to be 2y, each z to be 2y in the first and the third equation. And he got 2 equations out of 2 variables. Then he solved for x and y and got the value of x and y. Then at the end, he will substitute to get the z by multiplying the y value by 2. This is the answer for problem number 4. And this is the got it number 4. So you have, it's a small difference between the problem. Try to write the equations by yourself and check your answer by having the solution in here. Here are the questions. I put you the number of questions that you need to try to solve in your weekly plan. This lesson will be taken on 2 days or 3 days. So you can, as I told you, watch the first part, the substitution, practice on it, solve the homework for it, and then do the elimination, and the third part, which is how to write equations for your system. If you have any question, please let me know. Thank you.